Hello friends. Today we've got a quick little project. Even though it's been several weeks in the works, I'll hopefully make a pretty quick video about it. And it has to do with my teletype infrastructure, where we've got several units. Just to point out what these units are. This is a character generator and a distortion analyzer, just to see how the signals are going. This is a military, a Navy converter that I use for 850 hertz shift, 2000 hertz center frequency, military RAT stuff we do. This is my trusty ST-6, which will allow me to do 170 hertz typical shift for amateurs, and also provides loop supply. And this is what the project's about. And then down here we have a simple jack field where each item can be installed. Each item in the loop has a place to plug in, and it's all in series. Everything's in series. All these jacks and then of course we've got the teletype machines that are in series with all of that. But now, what's the problem? The problem is I have too much equipment, more equipment than this ST6's loop supply was designed to handle. The loop supply, while it provides 60 milliamp, you add more and more resistance into the loop, and it can no longer provide. The voltage drops, the current drops, and now you're getting something like 40 milliamps or something. And so I really wanted to fix this. So I decided that what I'm going to do is remove the loop supply from being within the ST6 to being external. It's having its own, having the setup have its own loop supply. And in order to do that, what I did is I found a Navy really stout, this is a loop supply used in the Navy. The nomenclature here is PP3495. I think there's an A in there, /UG. And it is a 120 volt DC. It takes 120 volts AC, converts it to 120 volts DC, and has a full 1 amp, 1000 milliamp capability. So that should be absolutely plenty to run everything I have. By the way, the other benefit of having an external supply is other teletype converters, for example, this Dovetron, that I would like to also be able to use, and it does not have its own loop supply, and so I just figured it's time to have an external supply. So if we take the top off this, we can see a little bit more of what it's got. On the front, it's got some fuses, it's got a lamp indicator, an on switch. Interestingly enough, it uses a magnetic amplifier, which is very interesting technology that had a very short period of popularity and then sort of disappeared, but still a very useful type of technology. It's got some transformers, the whole 9 yards, and it had two of those aluminum canned filter caps in here, the large electrolytics. We just took them out and instead put in some electrolytics underneath the base here. I probably should have left them and just disconnected them, left them for looks. Okay. All right, so what are we going to do here? So this will provide, as I said, 1000 milliamps, 1 amp, but we need to provide some sort of current limiting. Otherwise, the 120 volts DC just goes right across the coils of the teletype machines, and could cause damage. It's too much. So we need to add some current limiting capabilities. And with all that, I decided, why don't I make a panel, a control panel, that will allow me to vary and adjust the current, the loop current, as well as maybe, let's put a meter in place so we can watch the current, and maybe a few other goodies. So the next step, what I did was to go to using KiCad, or really I just drew it out on a piece of paper first, of what it is I think the schematic should be. Okay, so here is the schematic. On the left, you can see where the 120 volts DC 1 amp power supply comes in, and the power supply return. This is, of course, ground. And this is the schematic. We've got a little switch that I could use to both turn on the current and also bypass this whole device. I'll explain that in a bit. We've got a little neon indicator lamp. It has an internal resistor. We've got a fixed 1 kilowatt 50 ohm, 1 kilo ohm 50 watt resistor, and an adjustable 500 ohm 50 watt rheostat connected to a potentiometer connected in a rheostat function. That then goes through an ammeter. There's a fuse just for safety, and then out to a loop jack. And this allows me to, by using the adjustable rheostat, allows me to vary the current and get it right on the money for 60 amps. Now, just a quick show you what these switches do. So in this position, the power supply is introduced into the loop, and in the top S1B part of the double pole double throw switch is open, and so the current flows through the ammeter. Now, when we flip the switch, this disconnects the external power supply, but does connect the loop jack on this panel through the ammeter and circles it back around again to the loop. This allows me to turn off the current. For example, if I have another device providing loop current, got to be very careful not to run them at the same time. But it allows me to continue to have continuity in the loop and also continue to monitor the current in the loop. So before we can design a panel, we've got to find the parts, because the panel's going to be designed to accommodate the dimensions of the parts. And so, I looked through my junk drawer, found a few things, scoured eBay, got this really nice large ammeter with that has 60 delineated as opposed to 50 and 75 or something like that. So this is a really nice ammeter, and it's nice and big. I did not have, this is the rheostat. As you can see, it's quite the monster, wire wound, and you can see 500 ohm at 0.316 amps. So it's quite the monster. And got one of these cheap ones also on Amazon, 50 watts, and I think it's 1,000. 50 watts, 1,000 ohms. And then some miscellaneous stuff, a double pole, double throw switch. This is a little indicator, love indicator lamps on my equipment. This is going to be the loop jack, used to plug this control panel into the main jack field to provide loop current to all the devices. And, if you've seen my other projects, I rarely do a project without a barrier strip. This just makes wiring into the whole thing very convenient. Now, so once we've assembled all our products, all our components, and we've made our measurements for mounting holes, for example, I don't know if I can focus this. Some of these have, I think this is a good one. They have flats, so when you rotate them, the hole in the panel has to have flats. I'll show you that in a minute, so that the device does not rotate. So the next thing I like to do is to pick up a panel, an existing, cheap Amazon panel that I have lying around. That's the right height, in this case 2U, and start laying out all of the components to make sure that they've got enough room, they don't overlap in any way, they're not too close, and they're aesthetically pleasing. And I work on that for a bit, moving things back and forth until I'm happy with it. Now we're ready to create the CAD drawing and submit it. So here I'm using the Front Panel Express. This is this website that can make 19-inch panels for you. And I'm using their CAD tool that they provide for free. And it's a pretty simple thing. You drill, you create holes. You can select how thick the panel is. You can select any text you want engraved. You can select the finish. In this case is black powder coat. And then you submit it to them online. Of course, the most important thing is, since these are not cheap, key really is to make sure you measure 100 times and before you submit this, because once it's submitted, once it goes into their production queue, you can't change it and you're kind of stuck with it. So measure everything 100 times, lay it all out, and make sure you're happy with it. All right, so now that we've designed the panel, we submit it to the manufacturer, Front Panel Express, and we wait. And it takes about a week. It took about a week to get here. And this is how it comes. It comes shrink wrapped on a cardboard base. And let's take it out and see how it looks. Well, here's the panel. As I mentioned, I had it made in black to match some of the other panels in the rack. And unfortunately, they didn't have a good navy gray as an optional color. I would have definitely chosen that, but their grays are either too light or too charcoaly. And so here's you've got everything. There's some handles that we'll put in here. We've got the, I guess I'll lay it out and show it to you. Of course, these go on the rear of the unit, but this will, in the rear, will have this barrier strip. We've got the meter. And then we've got the loop jack, and you can see some interesting things about how we had to have this made, as I mentioned before, was, let's see if I can focus up close. Here you can see that the loop jack, the jack we use has two flats on either side, so it prevents it from rotating. Same thing, this is with the, this is the, for the fuse. Again, two flats, and this Front Panel Express makes it pretty easy to do that. Now this is for the rheostat, and there's this little other hole. I'll show you what that's for. So you can see here that, if we can focus, let me see if I can focus this. Not only do you have the hole for the shaft, but then you've got this little tab here that also prevents the whole unit from rotating as you rotate the knob. And so we had to make a space for that too. And let's see if I can show how that works. Okay, and you can see, hopefully you can see that the little tab goes through that extra little hole, and that way the whole thing is prevented from rotating. Right, so the next step is let's mount all the components, and then we can start wiring it up. Okay, well, there you've got it. This is what the finished loop control panel will look like. I got these on Mauser or Newark, I forget, some really nice little rack handles with a little finishing washer, which really makes it look nice with a little profile. But I like to make each project look a little bit more professional than the last. And I think these rack handles and the engraving and the nice powder-coated black panel really does the trick. So I think that's going to look really nice. So this is where the lines for the loop will, sorry, not the loop, but the power supply. Remember, we've got this navy power supply. That'll come in here. We've got the meter, we've got the fixed resistor, loop, jack, fuse, rheostat, switch, and indicator light. So now I just got to wire it all up and test it.